Alright, part 2 here. So, once you got the circuit redrawn here, you can start figuring out what you can calculate. And you had the right idea right off the bat. I saw that here. You knew that they gave you 1 amp flowing through that circuit, resistor, and that resistor being 2 ohms. So, using the formula V equals IR, so you wrote down 2 volts for that, which is correct. Now, what I think tripped you up is you didn't look for other spots where you could calculate something, which is understandable. This circuit's kind of annoying here. But they gave you enough information to figure out this side first. So right here, they got 1.5 volts voltage drop across that 5 ohm resistor, which means you can calculate the current flowing through not just that resistor, it's the current that's going to flow across all those resistors. Remember, the voltage is going to drop across each of these resistors, but the current is going to be the same. The current flow is going to be the same until you get another wire connected there. Since this is just single wire, there you go. So if you know 1.5 volts and 5 ohms, I equals VR. So 1.5 divided by 5, I think I calculated that as 0.3 amps. And again, notice that I labeled it right here, not just here, because you get 0.3 amps flowing all the way down. So this bubble here too is a reminder. I can't draw while looking at the camera. Jesus. Alright. So there you go. You know that 0.3 amps is flowing. That means you can solve these guys too. Because you now know there's 25 ohm resistor there and 0.3 amps is flowing. You got 10 ohm and 0.3 amps is flowing. So you can figure out the voltage drops there. So like a cooking show, I did this before. So that's going to give you 7.5 volts. And that one for R5 is going to give you 3 volts. So, this whole side is done now. On to part 3 here in a sec.